tools that you're going to see today. So I'm really passionate about the future of virtual design and construction through the utilization of BIM models, and also the future and the possibilities of parametric design, structural computational design, and then where it's actually going to be leading us in the future. And also I'm here to help and influence people at RBG on the best possible workflow from concept all the way through to construction. All right. And I think I wanted to share a little bit something about myself. I went to Spain in Madrid and I did a 400-hour course on parametric design, and it was so much fun. The course was run by Control Mad. It was all in English in Madrid, and I was there living and doing the course in Madrid with another 10 other students. And I enjoyed it thoroughly, and I did it only last year in September, and it's been super helpful for me. And what you're seeing here on these pictures here, we created a script that could generate a structural node for any type of centerline model. So that structural node then created like a solid shape. Then we could 3D print that solid shape. And then we ended up 3D printing all of the structural nodes and then creating a Rhino head, which was a lot of fun. And the place was in it's like a digital lab where they've got 3D printers, CNC machines, laser machines, 3D printers. And yeah, it was a whole lot of fun. So today is a story about a parametric design around the Story Bridge. Few things that we're going to go over today. We're going to go over the software introduction of what Rhino and Grasshopper is and how it's used for conceptual designs right through to construction. I'll give you a little bit basic understanding of what visual scripting is. And also we're going to go over how we create structural geometry parameters, how we can deconstruct a structural skeleton and the reasons why we need to do that before we go into parametric design. And what I mean by deconstructing a structural skeleton is basically the centerline model of the Story Bridge, the line geometry, not the complete structure, every single line element. We're just going to go over the basics of the line geometry of the structure, and then rebuilding that geometry, and then visualizing the 3D model and giving that, structural concept to a design, and how quick and efficient you can actually create a structural concept in Grasshopper and Rhino. A little bit, this is just some terminology that I've put together myself, what parametric design is. So parametric, expressing a set of quantities and numbers as an independent variables, collectively referred to as parameters in a mathematical operation. Design, translating a structural concept into an approved 3D model or a 2D drawing. Please, anyone ask me questions along the way if need be as well. So parametric design is translating a structural concept into an approved 3D model and or 2D drawing through parameters, which is providing design options, clear communication and visualization. Here are a few pointers why engineers should be using and learning parametric design. So with Grasshopper, you can use it to create generative engineering design options. It can create huge efficiencies in your project workflows for interoperability between production being your drawings at the end of the day, and then your design. Creating form-fitting structural concepts for an architectural work and collaborating with an architect. Controlling structural geometry. A lot of the time we have technicians controlling the geometry within Revit. With using Grasshopper and Rhino, you have a lot of that control in the engineer's hand with creating the geometry itself. Parametric design, creating parametric models, data visualization. You can import and export Excel spreadsheets and text files through Rhino, through Grasshopper as well, so you can read text files. Data processing, and also solvers of automation of concept structural optimization, which is done by using a plugin called Carumba 3D. Carumba 3D is free, with you being able to use up to 40, I think, structural elements. And I do recommend going on to carumba.com and having a look at that plugin for Grasshopper. It's very useful, and Carumba also has lots of tutorials on Carumba on how to actually use their plugin as well. So a little bit about what we're going to be doing. So what you're looking at here is just the front face of the story bridge, and this is what we're going to look at in more detail today. And this is just the centerline model of the front face. Then on the right hand side here, you can see these things are called sliders. These are parameters that you can change to manipulate the actual bridge, which will change the form, the shape, the number of structural elements. So you can see there, I've got bridge pier height, I've got the bridge width, the length of the left side, the right side, the length of the midspan, and then also you've got you see here, the bridge zone divisions. That's the number of vertical elements in each structural zone. And also changing the parameter of the arcs on the bridge itself as well. And what is this height of member of? That's the height of the midspan truss and the front truss. Now, here's just a brief understanding of what Rhino and Grasshopper is. Okay, so Rhino is a 3D modeling software, which is used right from jewelry design all the way through to structural engineering design and architectural design. So it's used for many things, not only architectural design and structural design, but also product design and jewelry design. It's used for many things. And now Rhino itself is the 3D modeling software, something similar to like how AutoCAD is. It has is a 3D modeling software also. Now, Rhino is a software that you can pay for, and I think there's a cheaper license for students as well. Most engineering firms and architectural firms will have Rhino at their offices. Also then, what Grasshopper is a plugin for Rhino, which is free. And then Grasshopper is the visual scripting tool, which is using all of the components to come up with a geometry. And that geometry is then only visually seen in Rhino. It's not a physical element in there. It's just like a visual. It's not like I can select that element. It's just visualizing it. So when you create something in Grasshopper, you can only visually see it in Rhino until you actually it's called baking. Like once you're happy with the geometry in Grasshopper, you can bake it, and then you can select these components and elements in Rhino. Okay, so here's a short video of myself playing around with the parameters. So these are the parameters which are built within Grasshopper, which are then changing the 3D visual in Rhino. So that everything that you're seeing moving on the right-hand side, that's in Rhino. It's all changing, the geometry is changing and manipulating to the parameters that I'm changing on the left-hand side with the sliders. You can see here, these are the right-hand side division, and then I go to the midspan division, and you can see how the script has been created to change the geometry with the sliders and not have anything break or move. And that's because all of the components have been created in a workflow where if there are certain constraints, it'll automatically change in the visual, in the 3D model. I will go over that in a little bit more detail in the next coming slides, but this is just a centerline model again, and just a real concept idea of what we're going to do. Oh, go again.
I actually have a question for you,
Yeah.
Chris.
Yep.
Why in that, why do you have only half of the story bridge?
Oh, only half the story bridge, because we don't actually need to do the both sides. Once you have a script working that's mirrored, you can just easily use one component and it'll mirror the whole entire geometry. So we don't need to create a script that's going to be, if anything needs to be duplicated in a script, you need to, you'll either move the same geometry to a certain location or you'll mirror it to a same location. You don't want to create more workload for yourself. So reducing that workload, finding the certain structural components that you need to design for, and that's how you break down the model. So we're only showing half of it because at the very end, we'll just mirror it. It's not worth our time doing both sides in the one script.
Thank you, Chris.
Yeah. Now, so I do a lot of tutorials for a lot of the people at Robert Berg Group. And what we like to do is like take a photo of an architectural building or a structural story bridge, or just a building that's a little bit of fun that we want to learn how to actually create the geometry. And then we take a photo of that building or bridge. And then what we try to do is called deconstruct. We try to deconstruct that building or deconstruct the bridge into how we're actually going to regenerate that structural geometry. Doing this is like something how we could practice on, you know, new buildings and things that might arise in our careers. So it's just like getting us ready for like when something comes up. So then we'll be like, oh, okay, this is similar to what I did on the story bridge. So then I can use it on an architectural form that comes up in the next job. It's just good practice. And once you get involved with using Grasshopper and Rhino, it gets really addictive because you've completed something and you really enjoy it. So here, deconstructing the centerline model. So I've gone here, we've got a left-hand side of the bridge here. We've got a right-hand side of the bridge here. And we've got a mid-span of the bridge here. That's my first breakup. And then you can see another, well, actually the first initial breakup will be mirror. Okay, I can see the left side and the right side of the sign. Let's just mirror it. So that's the first breakup. Next breakup would be mid, right-hand side, then left-hand side. Then the next breakup would be, okay, I have a left side with a distance. Then these purple dots are going to be my divided vertical structural lines. On the right-hand side, I've got my divided vertical structural lines. And then in the mid again, I'll have my vertical divided structural lines. And then I've got on the left-hand side, a top curve, and on the right-hand side, a bottom curve, a top curve, and then in the middle, we have just a straight, flat truss. So really just talking about like what type of structural center lines we might need to rebuild and how we're going to make it parametric. So looking at this, what we could make parametric is the lengths of each of these zones. So the lengths of LHS, RHS, and mid, the lengths, the size of them. And then we can also make parametric is maybe the number of vertical elements, which are, do you see these black lines? The number of vertical elements, because vertically, the architect might want to have more vertical structural elements through the frame, or structurally, we actually might need more vertical elements in the bridge. Then another thing we could have is a certain parameter for the K-brace between each structural vertical element. And then another final parameter that we could have is changing this top arc on the left side and right side so we can manipulate like that form of the bridge. So creating that quick and easy deformation of the curve to the architectural requirements or the structural engineering requirements. Okay, so then now I just wanted to go over a little bit about like structural understanding of geometry for grouping. So yeah.
I didn't want to break your flow, but I actually got a question. Does the software allow for simulation of loads on the bridge? a slider producing a load in a specific place, resulting in tension compression on joints. So like structural analysis.
Yeah. So just to be clear with everyone, we're just looking at a structural concept through a centerline model. This is just creating the actual form of the building. This is not doing any structural analysis. This is just visually seeing a concept behind creating the geometry. So this is creating a visualization for an architect. This is creating a visualization for an engineer on the 3D model. This is creating a centerline model, not for even analysis either. So what we're looking at is just a pure basic understanding of how parametric design geometry can be used. Because like, if you look at the story bridge, there are thousands of structural elements on this. You aren't going to create a quick and easy script to create a structural analysis behind using Grasshopper and Rhino. This is just a basic understanding of what Rhino and Grasshopper is used for, and you know, its basic capability. So there's no structural engineering analysis behind this. So what we're doing here is, in the structural understanding and grouping, is that if you look at the story bridge, you can see I've grouped these three because they have a truss system between each side face of one triangle, three triangles. And then if I go to this T2 group, it's got two triangles and then a truss on the bottom. And then if I go to the 1T, it's got one triangle with one truss. So why I've broken it up into different groups is because I'm going to have to create different structural scripts for each one of those cases. Okay. And then we go into the next one. And we're going to get into the script shortly as well. And then I'll show you like a brief live understanding of how the script works and how we've broken up the script as well. Actually, we'll just do that right now. Can you still see my screen?
Yes.
Rhino and Grasshopper?
Yep.
Okay, cool. So back to where I was saying how we were breaking up the form and the structure. You can see this is the script on the right-hand side. This is Grasshopper. On the left-hand side, this is Rhino. This is just a visual. So look, I can't select any elements. It's just a visual. Rhino is in the actual 3D modeling software where I'm creating shapes, lines, design, architectural designs. And you see that these are like actual physical elements within Rhino. And then when you script in Grasshopper, which is visual scripting here, this is visual scripting. And visual scripting is made up of like, these are called wires and these are called components, these elements here. Okay, so what we can do to give you a basic understanding of what visual scripting is before we go into too much of this, because this is quite scary and daunting sometimes, is if I had, say, a point position, right? Here's a point. I've created a point in Grasshopper, but I can physically not even touch it in Rhino, and I can move that point. So it's kind of like a workflow of like steps of movements on how to create a geometry. So then if I wanted to join a line from here to here, all I would need to do is go line and go from this point that I moved to the original point, and then I draw a line. And then if I wanted to, again, move that line, let's say in a different direction, it's actually automatically going in a Z direction. But if I say I want to move that in a X direction, you see it's moving in an X direction. And then I can actually put a distance on that. Oh, can you all see that? I'll just bring it in closer. It's in meters. And now I've got a parameter which is moving the distance of that line. And then also if this point here that I moved before, we moved it in a Z direction by 10 also, and I'm changing the parameter, which is this slider, which changes the height of the line. So it's like a workflow sequence that you need to develop within Grasshopper. So the first step would be draw a point, then a line, then I've moved the line, and then like, for example, you can loft, which is like between two lines, between these two lines. So you would have to place them together to loft and create a surface. So that's a basic understanding of a few components on how Grasshopper is creating geometry. So if we go back into the actual story bridge, I've broken the script down from a start point, which is here. And I'm just going to turn off everything and then show you step by step. So I've moved the point, then drawn the height of the first tallest pier. Then I've drawn the left-hand side of the story bridge. Then I've drawn the right-hand side of the story bridge. Sorry, the left-hand side of the story bridge arc. Then I've gone and drawn the mid. There's the right-hand side. Mid, and then that's the right-hand side arc here. See, I've really drawn just the outside of the story bridge itself. Then I've created lines between each group. Remember how we grouped it between mid, right, and then left. And then I divided those curves on the bottom by a value, which is these parameters, which is changing the number of vertical elements. So so once you have like in a real life project, you create a centerline model and the engineer is happy with that centerline model and the architect is happy with that centerline model, you can use that centerline model as an analytical line model for analysis. And then you bring that into your analysis software. So what I'm just showing is like how you can create various structural centerline models, and you could export out various possible design options and then analyze them. And you can easily change them automatically through the parameters that you create. So you can create multiple types of parameters to your design requirements that might actually change in the design, and then re-export out the centerline model. And we can show the bracing. These are the bracing options in different directions. We can show the K-bracing. Now, the K-bracing is pretty cool because you can actually change the position of the K-brace. For example, like you could move the K-brace in any position along here to either an engineering requirement or a structural requirement. So not just for the story bridge, I'm saying like for you to just understanding the possibilities of changing geometry and then analyzing it in various different positions. This is just a real basic script as well. And then we can just move that complete geometry and give it a width. So that's a little bit of the Grasshopper and Rhino there. So if I just go back to the PowerPoint.
Chris, I have another question for you.
Yep.
I believe this was back to the other question. This links to the other question that I said earlier. And it's basically there. This person asks, there has to be some understanding that the conceptual model will work. So I believe this person is trying to ask if it's you're doing these parameters and you're sliding them. How do you know they will actually work?
Work structurally. If the question is if they work structurally, the engineer needs to check these structural centerline models in their analysis software, if that's what the person means. If they work in the script, you'll know if they work or break when you're actually changing the parameters throughout creating the script. So like things can fail in your script creation and not be so smooth when you're actually creating something. I don't know how to actually break a script that I've already made work. But yeah, so like if they mean structurally, if this structurally can work, well, you have to get it analyzed by an engineer to make it sure that it structurally can work. This is just a visual understanding of what you can actually create in Grasshopper and Rhino.
So to clarify, it's more of a communication tool. Am I right?
This can actually be used to communicate your designs. Yes, it can be used for communication, but it's also used to create structural centerline models as well.
I see. Thank you.
Go on to. So maybe this answers the question. So Grasshopper and parametric designs are used as a communication tool for visualization and also structural geometry automation through parameters on a design. So what I'm showing is very conceptual. It's not ever going to be designed, what I just showed today. What I showed, that was really basic understanding of what the possibilities of parametric design, how you can change sliders, how geometry moves. Things can get very complicated further on real life projects. So parametric design is very useful in early stages of collaboration with architects. It's used from structural concepts all the way through to connection design. And what I'm really looking forward to in the future of parametric design is the future of automating structural cost estimations. So coming up with a structural design and getting a cost for that design, and then also being able to change certain parameters on that concept design and then providing a cost instantly. So that's where things could be leading in the future, I believe, for parametric design and cost estimations. And I think that's where we go into Q&A.
Thank you, Chris. That was a good presentation. We will now move to a Q&A. So feel free to turn on your mics if you have any questions on parametric design. I believe you've already answered some of my questions, actually. So
yeah.
I will ask them anyways, if that's okay.
Yeah, that's fine.
But this is to give some context to people who didn't listen. Well, I didn't invite you in, but this is context from before the session. I was having a conversation with Chris, and a lot of my questions had to do with structural analysis. Chris made it really clear to me that it's not more of the design, but more making the geometry. Is that correct, Chris?
Yeah, it's more about creating that geometry, and also once you get to understand Grasshopper and Rhino a lot more, you will end up using certain plugins within Grasshopper which do design, which you can freely go into in the future. But there is a lot of the back end to understanding Grasshopper and Rhino, which you initially need to learn to start to learn before you should be learning any of the complex plugins within Rhino and Grasshopper, such as Karamba. Karamba is an engineering plugin for Grasshopper. It's developed by a structural engineering firm in Austria and owned by an Austrian engineering firm as well. And it's used widely. And it does structural optimization and generative design and structural analysis. But you should always be using the structural analyzing tools that you learn at uni and also that you learn in the consulting firm and the approved structural analyzation programs that the structural firm is pursuing in their develop in their jobs.
Thank you. We'll start with question 1. What is the place of parametric design in the future of the structural and construction industry? And why do you think not all civil engineering firms are already using the software particularly?
Yeah. First question was, okay, so why aren't all engineering firms using Grasshopper and Rhino? One, it's incredibly hard to get people on board with a new software that the company hasn't already invested in. So a company might have already invested in a certain software that they're using throughout the company, and it's hard to press on with another tool in their office, and it takes a lot of people to get trained up, a lot of time. Also, sometimes you might need the right appropriate projects, and the certain company might not get a lot of the required high-end parametric design projects, because a lot of the time parametric design projects are used on like a high-profile project where you're going to make changes quite quickly or need to make changes quite quickly, or where you want to create design options. So when a client has a higher fee, they will be able to have more time to create a parametric design model where they can have more possible structural options, architectural options. So that's where you could use parametric design more. What was that first question, Nick? On the back of that, you said?
It was just what do you think the place of parametric design is in the structural or construction industry?
Oh, okay. So that kind of answered it.
Yeah.
So like it's used from concept all the way through to construction. Mm-hmm. So for like a certain connection design, you could create certain parameters behind, like even if I look at this connection here on the Story Bridge, you could generate that in Grasshopper and Rhino and copy it on every single location that it is typical. And then that certain plate design here could have a thickness. And that thickness could be from the engineer might not even know the thickness of that plate requirement yet, but you could set a parameter and have it at 50, 100 mil. And once the engineer has confirmed the plate thickness, you could update the plate thickness in Grasshopper and Rhino and then bake the model, and it's already generated over everywhere where that connection is already is typical.
And my next question is, I was going to say, how does the software allow engineers and architects to better communicate together? But I believe this presentation has already shown us how it does that.
Yeah.
Thank you for that.
Yeah, we can I'll just go quickly over that again.
Mm-hmm.
So, a lot of the time an architect will go off and create a structure, like an architectural form, and they might encounter a collaboration with a structural engineer. And if both architect and engineer both had parametric design skills, you will come up with a more high detailed concept design than you would ever have before, because you can create various options quite quickly together. So an architect could create the form, or the form being like the exterior face of the actual geometry. and then the engineer creating the structural skeleton behind that, and then it giving an offset from that form, and then working together on the same surfaces and collaborating closely together. And getting into that space would create a very high detailed, more detailed concept design than most people would in the industry.
I actually have received a question. This person seems interested in working in an architecture firm. Basically, this person said, conceptual design has no real limitations, and a lot of times this is presented via hand sketches. So with that original centerline model, which you displayed, what decided that original form?
So, well, the Story Bridge was designed a very long time ago, and I just did the centerline from what I was looking at physically now. But like, if an architect wanted to create a certain form or shape, you as the designer would create its own design parameters behind your vision on what parameter you needed to change. So that's how an architect would manipulate their own designs, through certain parameters to change the design shape or the certain patterns or other parameters required on the design. It would be up to the architect and the designer to come up with those parameters.
Next question. How does parametric design affect the way professionals in the industry work?
Okay, it affects us through, okay, one thing it does is that once you start using parametric design, people will see that things are created a lot quicker than the average 3D model. So you do get high expectations with when people understand that you have this capability and possibility, and they expect everything instantly. There are expectations that you need to communicate back to designers and architects that, you know, certain things will take time, and the disadvantages and advantages around what you created in parametric design. So that is one thing that does come up a lot often, is people not fully understanding what parametric design is, and always having to educate the person that you're working with when you are creating a parametric design model.
Thank you. Next question. What are the strengths and limitations of parametric design?
Strengths, I think you guys saw a lot of that already today, is like where you can manipulate, change the shape, change parameters, change things very quickly after creating a script. The limitations are, again, a lot of the time is the education behind the people that you're trying to influence to use parametric design. Not many people know the possibilities or the capabilities. So there are occasions where you've got to make a lot of effort to go out and do it, and then show them, and then people will be amazed about what the capability is and the possibilities are. Other things are, I wouldn't always use parametric design on every project. I would use it on projects where I think it'll be most useful, where I'm going to see changes occur quite often. However, that being said, I wouldn't stop anyone just using it on a typical truss, because if you're going to do it on anything, then you slowly building your skills up. And if you're just going to do a centerline model in AutoCAD and then bring it into another software, just generate it in Grasshopper. It's a good training session for yourself. And then that time will come when you actually use it on a project, and baby steps, really. It's just baby steps. There's a lot to learn behind parametric design, but it'll also give you that edge over a lot of other people in the industry.
And just to reiterate what you've just said, you tend to use it for projects that have a lot of changes. Is that right?
Yes. So a lot of changes, or when I'm creating a 3D model and I need the model done quite quickly, and I need to visualize it quite quickly for virtual design and construction, or for a Revit model, I need it, and the designer still hasn't come up with, their plate thicknesses or their number of bolts, or I will always create also like structural offsets from an architectural finish. Like that's always never confirmed by an architect all the time. What's your build up? What's that build up zone? So like there's your architectural finish, and then there's like so much of an architectural build up zone, and then there's a structural element. That build up zone can always change, which changes your structural geometry. So if you had a parametric design with having a architectural build up zone as a parameter, and you already have the whole structural skeleton completed, and the architect changes that build-up zone by 10 mil, you can easily change your parameter and all your centerline models are updated instantly. That's like a large advantage to using parametric design. And I use it when I know when you're gonna, it's always called like the picky person. You're always gonna have picky architect, picky engineer. What are they gonna change? And then what am I gonna create those parameters? The parameters are created by the constraints and also about the possibilities of what's going to change on the structure. Yeah.
Thank you. Next question. Is there a lot to benefit from investing into parametric design from a student perspective? I got to hear your story, but I actually want to know how did you hear about parametric design?
Yes. So since working in the Middle East, in Dubai, I started working on a lot of complex projects and people using Rhino and Grasshopper a lot. And then also, if you look at any of the most complicated buildings in the world, a lot of the time when you investigate how they've created a lot of these concepts, they're done in Rhino and Grasshopper. And a certain project came up and I was getting quite frustrated, and I was annoyed at myself that I couldn't even manipulate or change the geometry or get my head around the geometry. And it was on a high profile project, and I needed to step my skill levels up and get into developing my own career further. And that really influenced me going out and wanting to learn parametric design. And then also since then, just educating myself through so many YouTube videos, LinkedIn Learning, it's just given me more of a reason to keep pursuing parametric design even further. So I do recommend going on to LinkedIn Learning. I do recommend looking at Karamba YouTube videos, also any YouTube videos on Grasshopper and Rhino not any YouTube videos on Grasshopper and Rhino, but I do recommend LinkedIn Learning. I don't know if you guys have that, but also there is also some good YouTube channels, which is Parametric 3D, Parametrica. I actually could send you a list of stuff, Nick, of good YouTube channels that I like to look at for parametric design.
And if everyone was wondering, I'm going to send out a email after the end of this workshop with a feedback and a feedback form, as well as hopefully these YouTube channels. So thank you, Chris.
Yep.
And I think you answered Riku's question in the chat, which was, do you have any advice on learning how to construct with what you deconstructed in your head? So you said LinkedIn Learning, YouTube. I assume any form of online learning such as EDX maybe, or?
Yeah, so I'll send them all through to you, Nick. There's a lot online, but I do recommend LinkedIn Learning being the best possible and also up-to-date learning, because LinkedIn's always up to date, and I can see like every year they bring out tips and tricks on Grasshopper and Rhino as well, which is great to see. So it's always, whatever online software you're looking at, is to make sure that they're up to date as well, because software changes every year, so you need to make sure that they've got a 2020 release or something.
Yeah. Thank you for that. Next question. You have shown us what Rhino with the Grasshopper plugin can do. What are your thoughts of comparing Rhino with the Grasshopper plugin with other programs like SkySieve or Softetic?
To be honest, I haven't looked at these two programs that you're saying in detail at all. So I can't give you a clear positive and negative behind them against Grasshopper and Rhino,
Mm-hmm.
but I can give you one between Dymino, which is a plugin for Revit. Revit is a BIM software, which it has a Dymino. Now, Dymino and Grasshopper have their positives and negatives about them both, but this is just my point of view, is that I would much rather use Dymino for data-driven requirements and documentation requirements through Revit. Any geometry-driven requirement I like to do through Grasshopper. But look, this is just a personal, just my personal opinion, and everyone in the world will probably have their own personal opinions on which which visual scripting program that they would prefer to use. You know, you have people who love Autodesk, you have people who love McNeil. McNeil is Rhino and Grasshopper, and Autodesk is Revit. And I enjoy both of them, and there's uses for both of them. Yeah.
Next question. Which analytical software can be piloted via Grasshopper?
Look, so
like Space Gas or ETABS, for example.
Yeah. So a lot of the time you need centerline models. You can export out centerline models and also create models using Geometry Gym, which is a plugin for Grasshopper and Rhino. So the other thing is, like, you just need to really start with learning the basics of Rhino and Grasshopper before you get into all of these plugins that I'm mentioning as well. But you can use Geometry Gym to create SAP models, ETAB models. And another way is you can also extract data from a Grasshopper and Rhino file to create analysis models as well. So you don't actually need to create the geometry. You can create, end nodes, start and finish of a structural element, and then create it in ETABS or SAP. But that's getting in more complex regions on understanding parametric design. So let's start with the basics, and then hopefully you'll move into that into the coming future. Yeah.
That advice, Chris. Next question. If you're comfortable with sharing, how has parametric design helped certain Robert Bird Group projects that without would have taken longer, more resources, or would have taken more resources, or maybe would have not been even possible?
Yeah, great question. Look, there are scopes that we wouldn't be able to deliver without knowing parametric design. As a company, you to pick up some of these projects, you have to know parametric design to even finish them. Example, if you have a certain connection that is not typical over a whole entire project and that needs to be generated multiple times, you can use parametric design to generate that geometry requirement everywhere quite instantly with using parametric design. There's nothing else that you could use unless you're going to do it manually for every single location. So if there was, say there was 5 details and they were all different, you could use parametric design to automate all 5 details. And if you didn't know parametric design, you would have to manually go to each one and create it individually. And there are certain scopes that we have worked on that need to be using parametric design to actually deliver the project on time and successfully. And again, like the question said, is reducing the amount of resources required, because it's just a more efficient way of doing it on a project delivery a lot of the time. Yeah.
Yes. And to
also, sorry, another thing was like conceptual designs.
Yeah.
So parametric design is very useful in conceptual stages when you're going into structural competitions, structural engineering competitions. So, you can't instantly create a structural engineering 3D centerline model and Revit model without parametric design to create a structural vision as quick as you can with any other software. So you have to use parametric design to create that vision. And you're not going to do it with pinpoint geometry. So pinpoint, step-by-step pinpoint geometry. You're going to do it. You'll be able to create something, but it's going to take you a whole day, and then you're not going to be able to change anything. And then if you create a script for a whole day behind a structural a parametric design through one day creating a script, you can manipulate, change that geometry, and then the architect comes back, oh, I don't like this, I need to change this, my offset requirement changed. Okay, fine, I've already created it in my script, I'll change that, change this, So it's very useful in conceptual designs.
Do note that you use the word geometry a lot, and to be clear, parametric design doesn't replace structural analysis by any means. Parametric design just helps you visualize the model that you're trying to construct. It doesn't replace the fact that you have to actually do these calculations yourself and check them for yourself.
Exactly. So parametric design also can give you multiple design options for you to quickly analyze. You can create a structural truss and change it 5 times very quickly to create a 3D centerline model for your analysis. And then just analyze that those 5 options instead of having to recreate them each time.
And I basically wanted to say that because the next question was, is Grasshopper used for parametric geometry? How about change of material properties, load pattern, load case, etc.? I'm saying this because it doesn't replace.
No, it doesn't. It doesn't replace. But if you get further down in your career with understanding Karamba, some companies are using Karamba for concept structural optimization, which has material properties, has load cases. It's very useful. So I would, have a look into Karamba for Grasshopper and Rhino.
Okay. Next question. Basically, this has been answered, but can Grasshopper provide us with the optimized geometry of section, depth, width? If we define a constraint condition, can we link it to any optimization software like MATLAB? Basically, you've been saying Karamba?
Yeah.
So
yeah, I would look at that. Yeah, so that would be the answer. Karamba. Have a look at that.
And I think that answers all my questions. My last question would be, would you come back to deliver another, maybe more technical workshop in the future? Yeah,
I'd be happy to. There's a lot to learn with Grasshopper and Rhino. It'd be a good to get an understanding of where everyone is at, and if you're using it at uni, if you have, it could be good to understand where everyone's sitting at the moment. I do beginner sessions at Robert Berg Group. I do intermediate and advanced, because when you get into that advanced, you actually look at a lot at data tree structuring. So it gets quite complex with Grasshopper, and also in Grasshopper, you can use Python and C# to create structural designs as well. And also you can also add in certain equations and expressions into your designs as well. So it doesn't just stop at what you saw today. It can go right through to just using C# to create the whole entire geometry.
So you hear that, guys? Practice your coding.
Yeah.
But that concludes all my questions. If you like today's workshop and would like to see more of them, be sure to follow us on Facebook at QUT CESS and get a membership at qtcessmembership.getqpay.com. The link is in the chat here. And we are always trying to better and improve our events. This is the first of many more to come. So be sure to leave us any feedback at this link, which I will also send to everyone, but I will also put in the chat here. And I will send out the email. Thanks for coming, everyone. And do you have any last words, Chris, or any advice for every student here?
Thanks for listening, guys. Advice with parametric design is as soon as you get into parametric design and start actually creating your first form, it slowly gets addictive, and then you'll slowly get into a pattern of hopefully practicing as much as you can. So just give it a shot. It'll take some time. Have a look at what's available online. Also look at LinkedIn. Welcome to follow me on LinkedIn. Also, yeah, have a look at what I've posted on LinkedIn over the last 12 months, and you'll see a few examples on there as well.
So check out Chris on LinkedIn. And that concludes our workshop